Hello and welcome to a new challenge, this time Excel BI's Excel Challenge 533. As I first saw this challenge, I thought, oh, this would be very complicated. But then I remembered a trick I used in the last MAWC qualification round. If you have problem with something two-dimensional, make it one-dimensional. Also a trick I talked to you about in my 2D lookup video. So for this challenge, we will use this trick and it will make things quite a little bit more or a lot easier. So let's face this challenge here. So we should make those grid here with like this summing method. So for example, to get this value here, we need to sum those surrounding cells here. To get this value here, we need to sum those surrounding values. You see here the sum is the same. And for example, to get this value here, we need to sum up those values also. Yeah. So yeah, now you can see what we need to do here. And you see it's something that should be done from left to right and from up to below. So it seems to be something you need recursion for. And also I thought, oh, you need a recursion here, but then I thought, and yeah, you can also do this with like the one-dimensional approach. So first we have like 100 rows here. 100 rows because it's a 10 times 10 grid. Now, if we take something, it's called the mod to the power to 10. You see, mod is something. If you divide 11 by 10, then your mod will be 1 because 10 is only divisible by 10. 11 is only divisible by 10 once at a whole, and the remainder is 1. If you divide 12 by 10, the remainder is 2. If you divide 30 by 10, the remainder is 0. And for example, 36 by 10, the remainder is 6. So you could also do this with like 9 and other numbers, but this is a 10 row, 10 column, 10 column thing here. You can use this here. And then we will also use reduce here. Because with reduce, I can use the initial value and I can use this array here. And if you know reduce, I name this like my initial array. I can fill this and use this as my trailing array. Let's name it that way. So my initial value is a 1 and my array is a sequence of 99 rows starting at 2 and then lambda a b here is 100. If I now do a VSTACK, you can also see the rest of the thing, and you can see here, oh, we are starting here from all the rows from 100 rows here. Now I need here also let, so to have my mod, m is my mod of b to the power of 10, and if I now stack a and m, you see here I get here the mod for all of this. And I can now also wrap this with WRAPROWS to get this into the JSON form. And you will now see, oh, we have like this array as it is here. And I can now see, okay, if my b value, let's also make a table with only the b value. So a VSTACK A and B, grep 10. If my B value is smaller than 11 or smaller than 11, then I only have a 1 here. If my mod value is a 1, then I will need to think they're two-dimensional, and I will have something from above, so only this one here. And if you think of this as a two-dimensional thing, so to call it's a two-dimensional thing here. This one is the one here, and this one is the one following here. So I need to go 10 above, and here need to take the 2 here. So I can use something like an index function to take this here. And then I will sum up those values here. If I'm here in this corner, and if I'm here at a 0, I will sum up those surrounding values for this cell, for example. Let's also make this that you have all. So for this value cell, I need to sum up those. And therefore, I don't need here need to VSTACK the M. I need to have something like an if function. If B is smaller than 10, I will need to have a 1, otherwise let's say nothing. Or it needs to be smaller than 11, yeah. So this is my first one. Let's name this. So let's take an if-s because it's a little bit more easier, otherwise nothing. So if-s here, so it's if B is smaller than 11, we have 1. If then afterwards the more, so like M equals, I think it's 1, yeah, it's 1. If M equals 1, then we have index of B, because B is this row number we have there in A, B minus 10 plus index in A, B minus 9. It's an NA because we have here things where there isn't a value, otherwise nothing. So you see here we have a 2. We have here a value because there is nothing in it. Let's, instead of these brackets, name 0, so we will see this will work here. And we need to fill the other gaps in to make this a little bit larger. So if M equals 0, because we are at this line here, we take M equals 0, we take index of A, B minus 11 plus index A, B minus 10 plus index A, B minus 9 plus index, oh no, sorry, I made a mistake, not minus 9, this is for the whole thing. If we have everything, index A, B minus 1. You see here also this is filled, and we now need to fill this here, so like the middle ground. So otherwise, therefore there is the 1. We need to take, let's copy this in, then also at index A, B minus 11 plus, and here, plus index A, B minus 1. Close brackets, and you see the challenge is solved. So this seems a little bit complicated here what we did, but we only used like the reduce function here to face this iteration issue. We used here mod, which is a cool thing to use this in this two-dimensional approach, because you need to think, if we don't have this WRAPROWS function here, we have something that looks like this. So like here it is jumping wildly, but with the WRAPROWS appearing this into the JSON form. So we have like rows from 1 to 100 as a number, as my as my b value. And then we have the mod function, which gives me the remainder if we divide by 10. And then we use here an easy if-else function. And then you need to think with these indexes, you need to think in this one-dimensional approach, but with a two-dimensional view. So here, this cell here is, I have my A. A is my trailing from above, so everything, the A for this here, this cell here, is this everything of this in an it's like first the ones and then the two. The A value for this cell here is everything here, so row by row, everything into a single column there. And then I can say, oh, okay, this is cell number 60. So here there might be value 60. And then in this A array here, the index of this cell here is b minus 1, the index of this cell here is b minus 10, and the index of this cell here is b minus 11. And so I'm building slowly, with this reduced approach, I'm building slowly up this arrays here, and then I think two-dimensional, then switch it into three-dimensional afterwards to make it make the appearance two-dimensional. So this was complicated. I think also my explanation wasn't the best. If you have any additional questions, feel free to answer them into the comments. But as a learning from this challenge here, if you face something and you think you couldn't face it, it was the same with like I can potentially show this to you here with like the I have also a video on my round on my solving round here with the Microsoft Excel World Championship. I also thought, oh, here this treasure map, this was a complicated case. You need something recursive there, and this can't be. But afterwards I thought, oh, you can also, and this was like the same approach. I worked here with an offset approach here, and I made this map then one-dimensional, so two-dimensional instead of not one-dimensional, instead of making this using this in a two-dimensional manner here, and this was then could then be solved by me. Yeah, so as a learning out of this, if you have something two-dimensional, make it one-dimensional to solve it more easily. See you next time. Bye.